Now, just before we get started with you try 2, if you've got your running sheet beside you, you would have 3 examples that you would have listed next to substitution by now. So you've got this proving the sum of the coefficients is equal to 2 to the n. There's one example. That NC0 and NC1 equals 1 is another example that you can show or prove by substitution. And then this one, and just write it out simply with those 4 terms in it equaling 0. And when we finish this one, please add it to your running sheet beside you. And like I said, then any question you do in the exercise, past papers, anywhere else you come across something, an identity, and it's you find yourself showing or proving it by substitution, please add it to your sheet. Okay, so let's have a look at this one. And obviously it's going to be by substitution, but you won't always know that which one of the methods you need to use. So it's equally as important that as we are doing these questions, we are looking at detail, small detail. So let's have a look at it. And yes, we've got obviously the sum of coefficients. They're a little bit different this time. The power is 2n. That's not so bad because we see 2n occurring over here. We've got our constant, yeah, we can think of different ways to create a 2. This -1, you might be thinking a little bit problematic at the moment. And I guess it is really just a matter of exposure and experience that once you've seen how this -1 is created, then you'll be a little bit more open to when you see it in the future. You'll have this example to draw back on and say, oh, well, you know, I saw that this sort of thing occurred in this example, so maybe I'll need to use that particular technique. I'll just show you over here on the side just a little fact about 2 to the 2n minus 1. It's actually, if we think about it, as 2 to the 2n times 2 to the minus 1, which we're going to see as 2 to the 2n divided by 2, which actually came from something on this side being multiplied by 2n is equal to 2 to the 2n, where all this is the addition of those coefficients that you're going to see here. It's actually this. So that's, like I said, look, most of this is just once you're exposed to it, these are and yeah, you will need to have a look back over these examples, and that's why I suggest you put this on your running sheet. If you can't remember features of it just by looking at the running sheet, then you'll need to come back and look at the example in the notes, so that you're reminding yourself of these key little features. Okay, so we know that with this, the way that the coefficients look, we know that it's coming from an expansion of a plus x, certainly to the 2n. And I'd always suggest that if you've identified what the binomial is, then it's a good idea to write out its full expansion, certainly before we start doing any substituting. And in fact, it might be actually necessary for you to write out the expansion in its general form, even before you're able to identify what the substitution has to be. I'm just going to pause it, write that out, and start the solution. Okay, you can see there that I have really just focused on creating a 2 as my constant, and to do that I let a equal 1 and x equals 1. So substituting that into the binomial 2 to the 2n, which I'm pretty happy with, is 2n c naught. Not a little bit concerned about that, because there was no 2n c naught coefficient here, and 2n c1 I'm happy with because that appears, but there's no 2n c2 appearing up here. And I guess, and it's often what we do, we've jumped straight in without really looking, like I'd said, really look at every little feature of your identity. If we go back now and have a look at the identity, we've just realised there was no 2n c naught. These are every second coefficient, and this looks like the second last coefficient is here, but the last coefficient is gone. So realising that now and comparing that to what I have here, we know that we now need to eliminate something. We need to eliminate some terms. We want this term to go, we want the third term to go, etc. And I guess there are various ways to do that, but one way certainly is to create a whole nother binomial and an expansion, and then we will be simply adding them together. So again, this is a technique that yes, you need to see. It's probably not, it would take you a long time to come to figure it out for yourself. Hence I've put this example in here, because they're often little techniques that we may not stumble across it. So yeah, we need to be shown these little techniques. So I'm going to actually call that binomial and expansion 1, and then go into creating a second expansion. Now, I've chosen to let a be 1 and x be minus 1. I'm just going to pause the video again and write that out and then explain why you would do that, why you would make this choice for a and x. Now this expansion you've actually seen before, however the power wasn't 2n, but that doesn't make a great deal of difference. We know the important thing is that we're still getting a 0 in this spot, and we're getting this alternating sign. So 2n c0 minus the next one, add the next one minus, and so on. We know that this is going to be a negative because 2n minus 1 will be an odd number. 2 times something is even, subtract 1 will be odd. And a negative 1 to an odd power will be a negative. Whereas 2nc 2n, the minus 1 to the 2n would have been a positive, because obviously a negative raised to a positive, an even power will be positive. So I suppose the next strategic move then is to do expansion 1, subtract 2. So 2 to the 2n subtract 0 is nicely just 2 to the 2n. And then we look more closely at what's going on. We'll have 2n c naughts subtract this. So the 2n c naughts disappear, which we now know we wanted. We didn't want any 2n c naughts. 2n c1 subtract the negative is added, and we'll end up with 2 of those, 2 2n c1s. The 2n c2s disappear. This one, subtract this one, disappears. But if I'd put in the third, or the fourth term really, 2n c3, subtract that one would be added, and we'd end up with 2 of those. And so on until we get to the last one. The second last ones we would have 2 of, which would be called 2nc 2n minus 1. Then the last coefficients, or the last terms in the expansion, would cancel out, which is all really nice. Leaves us with this 2n minus 1 that we wanted up here. The only other thing now is we need to create this power 2n minus 1, but that will come out by taking out the 2 as a common factor and dividing both sides by 2, dividing by 2, which we saw up here, divided by 2, then you will subtract the power and you'll have the required identity.